A 5-meter height vertical wall has a saturated clay backfill. The saturated unit weight and cohesion of the clay are 18 kN per meter cube and 20 kPa respectively. The angle of internal friction of the clay is 0. In order to prevent the development of tension zone, the height of the wall is required to be increased. Dry sand is used as backfill above the clay for the increased portion of the wall. The unit weight and the angle of friction of sand are 16 kN per meter cube and 30 degrees respectively. Assume that the backfill of the wall is smooth and top of the backfill is horizontal. To prevent the development of tension zone, the minimum height by which the wall has to be raised is. Okay, here roughly I'll explain here in terms of figure. So there is a retaining wall whose height is 5 meter. Okay, there is a retaining wall which has a saturated clay backfill. There is clay here whose backfill is there and whose gamma sat is 18 kilonewton per meter cube and C is 20 kPa. Okay, and the angle of internal friction of the clay is 0. Phi is 0. So then in order to prevent development of tension zone, what happens? This is retaining wall. There is a backfill. So backfill will exert some pressure, right? As this is the clay, it will exert some tension at the top portion. Because of that, there will be a tension crack. Okay, tension crack means it will detach from the wall. Okay, so we want to avoid this detachment. Why there is a detachment? Because there is a negative pressure. Negative means if we have the formula, like suppose this is the total horizontal earth pressure, where it can be calculated Ka multiplied by sigma V dash minus 2C under root Ka. This is the active earth pressure. Okay, this active earth pressure, where you see this is having some value and this is having some value, but at the top portion, what happens at the top portion? This will be 0 because at the top point, at the top surface, this will be 0. There will not be any vertical effective stress. Because of that, this term will become 0. You will be getting only minus 2 root C Ka at the top. So slowly, as we go down, this portion will increase. It will increase. Finally, at one point, it will become 0. Then after that, it will become positive. Okay, after that, it will become positive. But at the top portion, the highest negative pressure will be this much. So as this is there, negative pressure, positive means come towards wall, negative means away from the wall. As at the top you are seeing this much negative or tension pressure is acting within the soil, it will be detaching from the wall. To avoid that, what is happening here? They are the angle of in order to prevent the development of tension zone due to this at the top, then slowly uh, as you go down, so dry sand is used. So I want to avoid that, the height of the wall is required to be increased. To avoid that, what did they do? They wanted to increase this retaining wall height. By increasing retaining wall, anything will happen? No. It's all about pressure is from the clay. Why are they increasing this wall? To keep another soil, so that tension zone will be uh, nullified. So what are they using? Which soil they are using? They are using dry sand. Above this, they are keeping some dry sand. Okay, above that they are keeping some dry sand. So dry sand, whose internal friction angle phi is 30 degrees, and what else? They're also using gamma of 16 kilonewton per meter cube. So these are the properties of the soil which they are using to keep the keep above the clay. So because of that, what happens at the top of the clay, there will not be zero earth pressure. Okay, there will not be zero effective vertical stress. There will be something, right? That something will be nullifying this effect, negative effect. So that is what the concept. Okay, now coming to these are the given properties of the clay. Now what they are doing, they are putting some, they are increasing the height of the retaining wall and they are keeping so sand here whose gamma value, dry sand whose gamma value is this much, gamma dry, and also friction angle is 30 degrees, right? Yeah, 30 degrees. Now what should we do here? What is the horizontal earth pressure? Let us say this is, we don't know what is that. Let us say this is height h. So horizontal earth pressure is, we know, as we discussed, ka multiplied by sigma v dash at any height 2c root ka. Okay, now if you calculate anywhere in the dry sand c is 0, that means you will get positive earth pressure, there is no issue. So there is no need to find out also because it's positive earth pressure. Because of which material the tension crack is developing, that is what we have to talk here. Tension crack or negative pressure will come due to this part. This part is occurring only in the clay. Now where will it be maximum? It will be maximum at this portion, because as you go down this will increase. As this increases, then it gets decreased. So our interesting point is at this point, at the top portion of, at the top point of the clay, that too in the clay, because in the clay only we will get this. So now at point P, let us say at point P, what is the effective vertical stress? Effective vertical stress will be gamma multiplied by h. H is, we don't know. So gamma is 16, gamma dry, because only sand we are keeping, 16 multiplied by h, because we are keeping sand, otherwise it will be directly minus 2c under root k. We want it to nullify. Okay, now sigma v dash, sigma v dash is 16 into kPa, right, at this point, due to dry sand presence. Now we will calculate sigma h at the rate p, at the rate p. Okay, also if I do, I can do just above, just below. Okay, just below, there are two things. Okay, sigma h at the rate p, just above and just below. What is just above? Ka due to sand. Let us say, I will say this as Ka1, Ka2, which has two different Ka values, because how to calculate Ka? Ka is 1 minus sin phi by 1 plus sin phi, right? What is Ka1? Ka1 will be 1 by 3. Ka2 will be 1 minus, its phi is 0 here. Phi is 0 in this Ka2. So it will be 1, right? So now if you take just above, at P only, but just above we are falling in sand. When you are falling in sand, here Ka1 will come. So sigma V dash, okay, at the rate P, this is at the rate P, okay, minus C is 0 in the sand, because we are falling in sand just above, okay, 0. So it will be Ka1 sigma V at the rate P. So it's a positive value. There is no issue with positive value because there is no tension crack just above. Till just above, there is no tension crack. Where the tension crack wants to form, initially before sand, before when sand was not there, at P in the clay. So that is why now just below, just below, when you go down, you have to consider Ka2, not Ka1, because you are just going below, just below, infinitely small. Okay, Ka multiplied by, and again it is P only. Okay, there is no change in it. Now you, as you are in the clay, now 2 multiplied by C multiplied by under root Ka2, right? This is what creating the deduction in the active earth pressure, right? This is what creating deduction in the active earth pressure. So initially it was positive due to the dry sand till just above. When you are going below, the maximum deduction will happen at the top of the clay. Okay, maximum deduction, because this is constant. Okay, just above and just below, this is constant. I mean, the sigma v is constant, and you are deducting this much. Suppose as you are going down, what will happen? This portion will increase. Sigma v portion will increase. As it will increase, you are falling more on positive side. Okay, so only at the top the deduction will be, the total value will be less, because you are deducting from the uh, you are deducting from a certain value below which this will increase. Okay, at the starting point only you are going to get minimum value of the horizontal earth pressure. That minimum horizontal earth pressure should not be less than 0. Okay, if it is less than 0, tension crack will form. So this minimum possible horizontal earth pressure, as you go down, again it will increase because of this because of this. Above this it is already positive, below this it will increase. Only at that point, at this particular junction, the minimum possible value of sigma h will be there. That minimum possible should be greater than 0. That is what our intention. So make that 0. Okay, Ka2 sigma v dash, just add p. Okay, minus 2 root c Ka2, it should be greater than 0. That value, this value, minimum possible horizontal earth pressure should be greater than 0. Okay, now if this should be greater than 0, so let us say equal to 0, or else let it be like that. Ka2 is how much? Ka2 is 1. Let us substitute the values. And sigma v is 16 into h minus 2 into c is how much? C is 20 multiplied by 1 under root 1 should be greater than 0. So 16h minus 40 greater than 0. H should be greater than 40 by 16. H should be greater than how much? What is 40 by 16? It is 2.5. Okay, it is 2.5 meter. Okay, because everything is in kPa or kilonewton per meter cube. So minimum it should be 2.5, or else it should be greater than 2.5. So minimum, what is its height? To prevent the development of tension zone, the minimum height is 2.5 meters by which the wall has to be raised. Thank you.